Hello students and welcome to our continuing lesson on trigonometric ratios of any angle. And I have a problem here that asks us to find the cotangent of theta if cosine of theta equals 1/4. What we've done in the past is to draw a triangle, and we can certainly do that, but I'm also going to do this using the trigonometric definitions and using a xy coordinate plane. So this, if you remember, is x over r. It's tempting to say adjacent over hypotenuse, and that's not incorrect, but with our work in trigonometry, we want to think in terms of x and r. So we have an r here that's 4, an x value that's 1. Okay, in other words, this length right here is 1. And we don't know what the height, this is our reference triangle, and we just want to figure out what's the vertical length right here. So let's find y. Y, using the Pythagorean theorem, is equal to square root of 4 squared minus 1 squared. That's going to give us square root of 15. So that means this point right here has coordinates 1 square root of 15. And if we want to find cotangent of theta, by the definitions, cotangent is x over y. We have x, which is 1. We have y, which is square root of 15. And if we can rationalize those denominators, this will give us an answer of square root of 15 over 15. And that's our final answer. And we should be happy and satisfied at this point because we have solved the problem, except that there's actually more than one answer. So I'll write this on the margins here so we can be clear. So there may be, and usually is, more answers than just this. And let's think about it. How can we possibly have another answer? It seems pretty clear. This is x, this is r, and this is cotangent, which is x over y, and we defined everything the way that we should. However, there's more than one way to draw this picture. We can think of this, I sort of arbitrarily drew this r going upwards, but it could just have easily gone down this way, and this is an r of 4. I use a different color here, so hopefully you can see it a little bit better, but we'll call this x, which is 1. And this point here is 1, and we need to find y. Well, y is square root of 15, but it's below the x-axis, so it's negative square root of 15 this time. We can find it the same way that we did before. Okay, so this is y, which is negative square root of 4 squared minus 1 squared, and that's negative square root of 15. So now if we want to find the cotangent, the definition of cotangent hasn't changed. Cotangent of theta is still x over y, but now y is negative, so you have x is equal to 1, y is negative square root of 15. Rationalize that denominator, and you get negative square root of 15 divided by 15. So we actually have two answers for this problem: square root of 15 over 15 and negative square root 15 over 15. So this example illustrates for us that in the world of trigonometry, especially when we have the more generalized definition of angle and trig ratios, these types of problems may produce more than one answer. And it goes along with the idea that if you're using the square root, it may be possible for you to have different answers, have a positive and a negative answer. It also goes along with the idea that the placement of our triangle matters. Here it's a triangle. This triangle is the same size, same shape, it's congruent, but the orientation of it is a little bit different. This one's pointing down below the y-axis, this one's up above the x-axis, and so we can have different x or sometimes different y values, which will lead us to having multiple answers. for some of the other trigonometric ratios. And so the previous two examples, the previous example with two answers, the example helps us and leads us right into this question, which is, for each of these scenarios below here, determine which trig ratio, which of the 6 trig ratios are positive, negative, or 0. So let's start with our first scenario. What if theta is between 0 and 90 degrees? Okay, which trig ratios would be negative, maybe like this, which would be positive, and maybe some of them are 0. So if we draw out our xy plane, theta between 0, so if 0 is right here, 90 is right here, so we're talking about all of the angles in here. Well, in this quadrant, this is quadrant 1 effectively, all of the x values are positive, all of the y values are positive, and we know that r is always positive, so I'll make a note on the side here, r is always positive. So basically all of the trig ratios are positive. For example, cosine theta is really x over r, but that's a positive number divided by a positive number, which is going to give you a positive number as well. Sine, same exact thing, y over r, which is a positive number over a positive number, which will give you a positive number. So we can answer this question relatively quickly, and we can say that, in fact, for this scenario, all ratios are positive. Let's look at the next example. What if theta was between pi over 2 and pi, radian? And just for those of you who like to look at it degrees, this is saying 90 degrees and 180 degrees, which is this quadrant right here. It's effectively quadrant 2. And in this quadrant, all of the x values are negative. All of the y values are still positive. Let me make some space here and write this a little bit neater. This is Q2. All of the x values are positive. I'm sorry, all of the x values are negative. I don't know what I'm saying here. All of the x values are negative. All of the y values are positive. And so some of the ratios may be negative, some of them may be positive. Well, let's look at which ratios involve an x. Cosine, secant, cotangent, and tangent. So this is x over r, so that's going to make it negative. This is r over x, and again, r is always positive, x is negative in this case. Cotangent is x over y, so this is a negative over a positive. And same with tangent, it's y over x, which is a positive number over a negative number. Okay. So we can look at all these and we can say that all of these here are negative, and the only ratios that are positive are the ones that use y and r. So that's sine and cosecant are positive. Let's look at two more examples. Now, what if theta was on the interval from pi to 3 pi over 2, so that's this region right here, and this is when you have a negative x and you have a negative y. So looking at this, we can now answer all of the trig ratios. So let's look at cosine. This is x over r, which is a negative over a positive. I'm sorry, I don't want to put this fraction bar in here. I'm just going to write it negative, positive. So that means cosine is negative. How about sine? Well, sine is y over r, so this is negative over positive. So that means sine is negative. Tangent y over x, a negative over a negative, so this one's actually positive. Secant, r over x, that's a positive over a negative. Cosecant, r over y, that's a positive over a negative. And finally, cotangent is x over y, that's a negative over a negative, so that's going to give you a positive. So in other words, these ratios here are some positive number divided by some negative number, or vice versa, so that's going to give you a negative value. And these values down here is a negative over a negative, so this is going to give you a positive value. So all that we're really doing here is drawing out the pictures, seeing what quadrant we're in, and investigating using what we know about dividing and adding positive and negative numbers. Let's finish this out with the last part of this example. So I've written this as theta is in the interval of negative pi over 2, so that's down here, to 0, so that's this section right here. In other words, Q4. And in this section, x is positive and y is negative. And we can also write this another way. From negative pi to 0, we can also express this as, we can also say this is the same as from 3 pi over 2 to 2 pi. Those are the exact same way of saying the same things, and we can investigate this all over again like we did before. So cosine, and I'm going to go quickly. Feel free to pause and rewind and ask me or ask your teachers if you have any problems with this, but let's continue. Cosine theta is x over r. So x over r, this is a positive over a positive, so that's going to give you a positive. Sine of theta is y over r, so this is a negative over a positive. Tangent of theta is y over x, which is a negative over a positive. Secant of theta is r over x, which is a positive over a positive, because r is always positive, and x we know here is positive. Cosecant is r over y. R is always positive, y is negative in this case. And then finally, cotangent is x over y. X is positive, y is negative. So this is positive, that's it. These two are positive. And then the other four that we have remaining here are all negative. And you can see this whole thing, this whole process, these 4 examples or 4 problems just help us to understand where these ratios are going to be positive, where they're going to be negative, by analyzing which part of the quadrant that they're going to fall into. So given an angle of rotation, if we rotate a certain an angle, we should be able to tell what quadrant it's in, and using that information about the quadrant, we can figure out whether the ratios are going to be positive or they're going to be negative, which is actually connected to this example that we did up here a while back. We can see up here that if you have a something that is in the 4th quadrant right here, that the cotangent has to be a negative number, just like we found out in our scenario here. Or if you have something in the 1st quadrant, then the cotangent has to be a positive. In fact, all of the answers in the 1st quadrant have to be positive. Now, if you have like a cosine that's positive, well, that can occur in the 1st quadrant or in the 4th quadrant. Okay, so it gives us a better picture, better understanding of what these values are and how do we estimate and and check our work, and in the long term it'll help us understand trigonometric functions. So to end this particular video, this segment of the lesson, we are going to look at one more example that says find secant of theta and cosecant of theta if the cotangent of theta is -4/3 and the sine of theta is greater than 0. Okay, so that's a lot of information. There's actually 4 trig ratios that's involved here. We're given information about 2 of them. We know one of them is equal to -4/3. We know that one of them is positive, and we're asked to find the other 2. And again, if you notice from the example that we just did earlier, we can have multiple answers to these problems, and we need to be very careful about where and what quadrant we draw these things in. And so if sine of theta is positive, so we know that sine of theta is equal to y over r. So if sine is positive, then we have to conclude that y is positive. So that means y is either in this quadrant, Q1, or in this quadrant, Q2. And we're not sure which quadrant it's in until we look at this fact. Cotangent of theta is -4/3. So if you remember, this definition of cotangent of theta is the numerator is x and the denominator is y. Okay. We already know that y is positive, so we know that y has to be equal to +3. And then in order for this to be -4/3, x has to be -4. So if you look at this fraction at the start, you don't really know if y is supposed to be positive or x is supposed to be positive, but using this additional piece of information, we know now for sure that y is the positive number and x is the negative number. So if x is negative and y is positive, this suggests to me that this is in Q2 over here. So now we've narrowed it down. I am going to draw this x as -4, okay, and y is +3. So this is -4, +3. We are looking for secant and cosecant. So this is x, this is r over x and r over y. So we're going to need to find r. Well, r is the square root of -4 quantity squared plus 3 squared, which is actually 5. So that was very convenient. And so secant of theta is r, which is 5, over x, which is -4. And we can say this as -5/4. Cosecant of theta is r, which is 5, over y, which is 3, +5/3. Now, if we didn't have this extra bit of information here, we could still have done it, but we have to do it twice because there's actually 2 possibilities. You could have had positive y negative x like we had here, or you could have also had something like positive x. We could have done something in here, positive x, and where y is negative. So we needed this information to tell us for sure that it is in fact in Q2. And so this video is getting kind of long, almost 20 minutes already, even though we didn't do a whole lot of problems. But it's a good time to end it here. It sort of ends one more segment in our lesson on trigonometric ratios. I will start another video where we will discuss the unit circle, which is a highly useful and powerful tool for us to work with trigonometry.